Synchronizations. Synchronization are program constructs aiming at enforcing an order between independent tasks, or to ensure mutual exclusion, for instance, to protect some shared resources. You want to avoid synchronization because they have a strong impact on performance, but correctness is a higher constraint, so you need them when appropriate. Let's look at an example where you want some strong synchronization between threads. Assume this is a producer thread. Assume this is a consumer thread. In that case, you want, when the data is produced, the consumer to be aware that there is a data, and you want the producer to wait for the consumption of the data. So this will require some synchronization between the two threads, and in that particular case that will be conditional variables that we will see later. So the kind of synchronization we find, mutual exclusion with lock and a variant of locks called spin locks, barrier, conditional variables, join operations, and messages. We have already seen those two. So mutual exclusion is the method to protect access to shared resources, and you want to serialize the access to these resources. So for instance, assume this thread is accessing some shared variable and updating it. You want the other thread to wait, this is here, before they can do the same. So for instance, only when this thread will release a lock that this thread will be able to access the shared resources. Same thing here. So they are very similar to binary semaphores, and they are used to implement monitors where you encapsulate some shared data and all the operation to manipulate this shared data between threads. This is the pthread interface for locks. The spin lock is a variant of the lock we just seen, but instead of getting, when you enter a lock and it's not available, you are switched off, the thread is switched off. In that case, it keeps polling, it keeps looking at if it can get in. So for instance, this is what's symbolized here. You want to get into a critical section, and so you check, is it possible? No, and so you check again, is it possible? Etc. So in that particular case, the thread polling the lock is kept active. And one of the idea behind that, it's because it will be more efficient for short critical section. You don't want the thread to be switched off. You want the thread to keep looking at, so it's actually access the shared resources as soon as possible. Interface is very similar to the one you have for the regular lock. Conditional variable. In that case, you want to be able to wake up a thread on a signal. And in this case, let's look at this code. I have a producer and I have a consumer. Producing a value is just counting plus plus and displays a value. Okay. And when this is done, I want to tell the consumer the data is there. So I do send a signal on a condition, and in that case, the pthread can't wait that put the thread to sleep while the condition is not met is wake up. It consumes a value, that means in here printing the count value, and then it sends a signal to the producer that was waiting for this conditional variable. One of the particularities of these conditional variables is that they have to be into a lock-unlock mutex section. Look at this code on the SVN repository, and you can try this exact code that implement synchronization scheme similar to the one given in example at the beginning of this presentation. Another kind of barrier that is very important of synchronization is barriers. In that case, you want that a set of threads reaches some program point before everybody else resume its execution. Let's take an example. In here, I have multiple threads. Assume they are computing some arrays. They are computing some arrays, and I want this array to be available for all the threads later on. Okay, so they will all access elements of the thread. So what I want to make sure is that when I get after this point in here, all the threads have computed this array. So I put a barrier at the end of the computation of the part of the array for each thread, and only when all the threads have entered the barrier, then they can go on their execution. In that case, this thread is the latest one, so it is the one that actually frees the other threads. This one was the first one entering the barrier, and it's waiting for the other one to come in. So let's look at the exercise for this part of the course. So look in the SVM for synchro thread XO, and this code is not computing correctly because it's missing some synchronizations. So add a barrier and a lock to make sure that the parallel execution is correct. Before you do that, try to understand what the code is doing. Another thing is look at what on the web, what transactional memories are, and what they are providing. They are kind of becoming more important because Intel is having a new instruction set that implements them. On the pthread tutorial, you can go to this address, and for transactional memory there is a site with a lot of references. See you in class.